Data Encryption Standard or DES, a block cipher algorithm that creates plaintext in blocks of 64 bits and transforms them to ciphertext, utilizing key of 48 bits. It is a symmetric key algorithm, which defines that similar key in use for encrypting and decrypting information. Data Standard Encryption or DES, a symmetric key block cipher invented by the National Institute of Standard and Technology or NIST. In 1973, the National Institute of Standard and Technology invented a request for a suggestion for the National Symmetric Key Crypto System, a scheme of IBM, a modification of a project known as Lucifer, and was approved as Data Encryption Standard. Data encryption standard was invented in the Federal Register in March 1975 as a plan of the Federal Information Processing Standard or FIPS. Data requirements first is provide high level of security on commercial standards. Security must not depend on secrecy of algorithm, must be easily and economically implemented. Data encryption standard is a block cipher, as shown in figure. Data encryption and decryption with data encryption standard. They have a 56-bit key. In the right side, they have 64-bit plaintext and also they have 64-bit ciphertext, which is the data encryption cipher as seen in the data encryption standard reverse cipher.
Initial and final permutation tables. How to read this table? The 58-bit of input X will be the first bit of output IPX. The 50th bit of X is the second bit of IPX, and etc. The initial and final permutations are straight P boxes that are inverses of each other. They have no cryptography significance in data encryption standard. Example: find the output of the initial permutation box when the input is given in hexadecimal as 0x0000008000000002. The solution is only bit 25 and bit 64 are 1s. The other bits are 0. In the final permutation, bit 25 becomes bit 64 and bit 64 becomes bit 15. And the result is 0x0002, 0000, 000, and 0001. Data encryption standard uses 16 rounds. Each round of data encryption standard is a Fistel cipher. Separate message block into two 32-bit half, Li and Ri. Introduce confusion by using a complex nonlinear function f. F has two inputs, Ri and a 48-bit round key Ki. Introduce diffusion by adding Li and the output of F. And this is the figure around in data encryption standard. Data encryption standard function. The heart of data encryption standard is the data encryption standard function. The data encryption standard function applies a 48-bit key to the rightmost 32 bits to produce a 32-bit output. And this is the figure below the data encryption standard function.
Since Ri is a 32-bit input and Ki is a 48-bit key, we first need to expand Ri1 to 48-bit. Expansion permutation box. Since write input is 32-bit and around key is a 48-bit, we first need to expand write input to 48 bits. Permutation logic is graphically depicted in the following illustration. Although the relation between the input and output can be defined mathematically, DES uses table 6.2 to define this p-box. The XOR whitener, after the expansion permutation, DES does XOR operation on the expanded write section, and the round key is used only in this operation. Substitution boxes. The S box carry out the real mixing confusion. DES uses 8 S boxes, each with a 6-bit input and a 4-bit output. Refer to the following illustration. On the illustration, there are a total of 8 S box tables. The output of all 8 S boxes is then combined into 32-bit sections. Straight permutation. The 32-bit output of S boxes is then subjected to the straight permutation with rules shown in the following illustration.
Example, the input to Xbox One is 10011. What is the output? Here are the solution to get the output. If we write the first and the 6 bits together, we get 11 in binary, which is 3 in decimal. The remaining bits are 001 in binary, which is 1 in decimal. We look for the value in row 3 column 1. In the table X box, the result is 12 in decimal, which is binary is 1100. So the input 10011 yield the output is 1100. Straight permutation. When we said permutation is an arrangement of objects in a particular way or order. While dealing with permutation, one should concern about the selection as well as arrangement. Key generation. The round key generator creates 1648-bit keys out of a 56-bit cipher key. Parity bit drop table. Parity dip table is a lookup table to use to remove parity bits from binary data in order to improve transmission efficiency in computer networks. Number of shift bits. The number of shift bits required is an important consideration when working with binary data and can have a significant impact on the performance and accuracy of the program. Key compression table. Key compression table plays an important role in the security and efficiency of many cryptographic algorithms by enabling the generation of a set of round keys from a single main encryption key.
Example. Although the two plaintext blocks differ only in the rightmost bit, the ciphertext blocks differ in 29 bits. This means that changing approximately 1.5% of the plaintext creates a change of approximately 45% in the ciphertext. So, we can see in this illustration that the 1.5% of the plaintext creates a change of approximately 45% in the ciphertext. Completeness effect. Completeness effect means that each bit of the ciphertext needs to depend on many bits on the plaintext. Design criteria. The design S boxes. The design provides confusion and diffusion of bits from each round to the next, and also X boxes are nonlinear transformation of a few input bits that provide confusion. Number 2, P boxes. They provide diffusion of bits, so P boxes simply shuffles the input bits around to provide diffusion. Number of rounds DES or Data Encryption Standard. Or Data Encryption Standard is a symmetric key algorithm for encryption of digital data. DES uses 16 rounds of Feistel ciphers. The cipher text is thoroughly a random function of plain text and ciphertext. DES weaknesses. During the last few years, critics have found some weaknesses in DES. Weaknesses in cipher design. Number 1, weaknesses in X boxes. Two specifically chosen inputs to an S box can create same output. Number 2, weaknesses in P boxes. Initial and final permutation have no security benefits. The first and fourth bits of every 4-bit series are repeated. Number 3, weaknesses in key. The keys create same 16 round keys. Semi-weak keys create 2 different round keys. Possible weak keys create 4 distinct round keys. Key complement. There are 4 weak keys. After parity drop operation, a key consists either of all zeros and all ones, or half zeros and half ones. Weak keys create same 16 round keys. So in this illustration, we see in the left side the key before parties drop 64 bits, and in the right side it is the actual keys or 56 bits.